One, we have first question. So we should be going with the graph. Okay, this is y, this is x. So this is the graph. Okay, and this is point one. So we can see that, and for this we have graph like this. When we have x equals to 1, 2 to the power, we will find that 2 to the power x minus 1 is equals to 1. At what point? When x is equals to 1. So it is when we have x equals to 0, the curve goes from here. When x is 1, it is 1. When we have simple graph of 2 to the power x, it will go from here. No, that x is x minus 1. So it will go from here. So that graph will come out to be from here. And it will go here. So we can see that when x is less than 1, this graph is minus of log x base 10. And this is when x is less than pivot. We have one coordinate axis. When x is 1, this will be 0 and x should be bigger than 0. So this will go something like this. This is log 10x. And when this we have kept log, what we did is that we kept log x base 10 equals to 0. So x was equals to 1. So this was the critical point for this. Similarly, we did 2 to the power x minus 1 equals to 0. We got x equals to 1. So what we did, if it is x equals to minus 1, so this is the line with y equals to minus 1. And now we have to draw the graph. So at x equals to 0, it will be 1 by 2, which is minus 1 by 2. 1 by 2 minus 1 minus 1 by 2. And x equals to 1, it is 0. So this is somewhere like this. The graph is going like this. And staying going up to x tending to infinity, it will be minus infinity, it is minus 1. So it is minus 1. So what we can come to know is that we are taking the modulus, isn't it? So this modulus, this complete graph will go like this. And this complete graph will go like this. So what can we define from here is that if x is less than 1, we have minus log x base 10 minus of 2 to the power x minus 1 plus 1. And when x is bigger than or equals to 1, it is log x base 10 plus 2 to the power x minus 1 minus 1. This and this is the two equation for different cases. Now we'll proceed to, I will try to make it more simpler for you all. Okay. So I will be moving to next question. Question number 2. We are given like this. Log x base 2 whole square like this. It will come out to be log x base 2 minus 2 into log x base 2 minus 1. So if you see, the critical points are what? When this is equal to 0 and this is equal to 0. So this is what? X equals to 4, x equals to 2. So we'll simply plot the graph. When x is 2, when x is 4, when it is x is 4 plus, both will come out to be positive. So this is somewhere positive. When x is less than 2, x is bigger than 2, it is positive, and this is negative. So the curve will come like this. So curve will come somewhere like this. And when x is less than 2, bigger than 0, this will come out to be negative, and this will also come out to be negative. So negative, negative, positive. So it will go somewhere like this. So what is our conclusion? That this negative part will become somewhere positive. So the equation will come out to be, when case, we take cases, okay? Case 1. X less than 2. It is log x base 2 whole square minus 3 log x base 2 plus 2. So this is when x is less than 2 and when x bigger than or equal to 4. It is minus log whole square. Question 3. 5x square minus 4x plus 5 equals to 25. We'll put it 0. X square minus 4x plus 5 should be equals to 2. We'll get x equals to 3 and 1. So we have one graph. X is 1, x is 3. So this will be equals to 2 when it is between 1 to 3. 1 to 3. So that will be negative. So we have case 1. x bigger than equals to 3 and x less than 1. It will be bigger than equals to 2. This will be bigger than equals to 2, then it will be bigger than equals to 25. So we have, then the graph is 5x square minus 4x plus 5 minus 25. Case 2, when x is bigger than equals to 1 less than 3, it is 25 minus 5x squared minus 4x plus 5. These are the solution.